Cofunctions is a continuation of sine, cosine, and tangent. Specifically, we'll be working with sine and cosine. So sine and cosine of complementary angles. The sine of any acute angle is equal to the cosine of its complement. And I'll explain this more when we go through the model. In previous years, I've had students complete this next section by themselves, but I'm just going to briefly go through it in this video just so we can talk about what cofunctions are. So if you read this chart, our investigation, the first part says from reference angle A, which is going to be, should say 28 degrees. Oh, sorry, this should say 22 degrees. Guess I didn't do very good at adding here, so 22 degrees if we could all fix that. Okay, so focusing on angle A, which is 22 degrees, if anyone missed why I changed that, 22 plus 68 plus 90 is 180, so that was just a typo. Okay, so if we're looking at the sine value of A, we are going to say that the sine value is 15 over 40, opposite over hypotenuse. So sine would be 15 over 40. If we're looking at the cosine value of A, cosine is always adjacent over hypotenuse, which would be x over 40. And if we're looking at the tangent value from angle A, you're looking at the opposite over the adjacent side, which is 15 over x. So I wrote those quickly from my abbreviation of SOHCAHTOA. You should all be thinking about that in your head anytime you're working with trig values. The next part of the investigation is to work from reference angle B, which is here at 68 degrees. If we write our sine value from B, our sine value is the opposite over the hypotenuse. So we would be writing our sine value as x over 40. If we write our cosine value, we're looking at the adjacent side over the hypotenuse, or 15 over 40. And lastly, if we're writing our tangent value from angle B, we would be writing the adjacent side, the opposite side over the adjacent side, which would be x over 15. So we just listed the trig ratios for everything that we were asked to in this chart. And right here it says when you list the trig ratios for both acute angles, you notice some interesting developments. And what do you observe from the table? So what I was hoping for everyone to observe, and again, usually we do this in class, obviously this year is a little different, but what you should hopefully observe is that there's some similarities. For example, sine of A and cosine of B both have a fraction of 15 over 40. That means sine of A is equal to cosine of B, which is equal to 15 over 40. I was also hoping that everyone recognized that cosine of A is x over 40, and sine of B is also x over 40. So that tells us that cosine of A is equal to sine of B, which is equal to the ratio of x over 40. So we have multiple values that are going to equal the same thing. Our conclusion from this chart is that if angle A and angle B are acute angles of a right triangle, then we know that sine of A is equal to cosine of B, and vice versa. We could say cosine of A is equal to sine of B, basically what we wrote up here. So we have cofunctions, or we have functions that are equal to the same thing. So since the measures of these acute angles of a right triangle add to 90 degrees, we know these acute angles are complementary. Recall that complementary angles are two angles that sum to 90 degrees. From this, we can establish the following relationships between sine and cosine. And this is specifically what cofunctions are, so you are going to have to know what these values, or how to use these values. So sine of theta, recall that theta just means an angle, any angle, is equal to cosine of 90 minus your angle value, or your theta value. So theta is just representing an angle. Also, cosine of theta is equal to sine of 90 minus theta. So if you have a sine value of a certain angle, it's equal to the cosine value of its complementary angle. If you have a cosine value, then the sine value is the same for its complementary angle. We're not going to be dealing too much with tangent, but right here it says, what about tangent? So the tangent of angle A is the reciprocal of the tangent of angle B. And I'll just make that as a quick note. Okay, using cofunctions to answer the next couple of questions. So the directions say to use complementary angles and cofunctions to solve for x. So if we know that these are cofunctions and we know that they're complementary angles, then we can use this data here and we can find our value of x. What I'm going to do is I'm going to set up my cofunction as sine of 30 is equal to cosine of x, and these are both equal to 1/2. Notice that both of these expressions are equal to 1/2, so I set everything equal to itself. So if cofunctions are complementary angles, that means this number here and this number here must add up to 90. 30 plus x is equal to 90. Therefore, x is equal to 60. That's what you're looking for. Cofunction angles sum to 90 degrees. If I was to write this out, I would just indicate that cosine of 60 is equal to 1/2. Okay, we solve for x. That means that the cosine of 60 value is equal to 1/2. We're going to do the same thing for number 2. We see that sine of x is equal to 1/2 and cosine of 60 is equal to 1/2. So I can write this out as sine of x is equal to cosine of 60, which is equal to 1/2. We know that these two angles are complementary, so we know that x plus 60 has to equal 90 degrees. This indicates that x is equal to 30. And from here we can indicate that sine of 30 degrees is equal to 1/2. Cofunctions might sound like they are difficult at first or a little bit confusing because you're dealing with multiple functions, but cofunctions should end up being fairly basic. Again, because what you're doing is you are just finding a complementary angle, or you're just setting an expression equal to 90 degrees. And for 3 and 4, I'm going to complete 3 and then I'm going to ask that you guys try number 4 by yourself. So number 3 and 4 look a bit different because here we just have two functions that are equal to each other. But we're using the same process, so we still know that if these are equal, that means that this angle and this angle must sum to 90 degrees. So I can set up an expression here. I can do 3x plus 10, that's my first expression, plus x plus 24, second expression, is equal to 90. When I'm solving, these parentheses are not needed. So I can add my common terms, 3x plus x is 4x, plus 10 plus 24, which is 34, and this is equal to 90. Subtract 34 from both sides, 4x is equal to 56. Divide both sides by 4, and x is equal to 14. Now what you should do to check your work is you should take this and you should substitute it back into these expressions and make sure they come out to be true. Okay, I'd like everyone to press pause and I would like you to try number 4 by yourself, and then you can come back to the video, press play, and you'll see me complete number 4.